Okay, so now we're going to move on to chapter 2 since chapter 1's done. Chapter 2 is all about rational and irrational numbers. Okay, so a rational number, let's talk about irrational first. That's the easier one. Irrational numbers never end and never repeat. Repeat. Okay. Rational is everything else. Okay. So another thing that I like to talk about is the only irrational numbers you know so far as like an 8th grader are going to be pi and then a square root of a non-perfect square. Okay, so a square is a number times itself. So like 25 would be a perfect square because 5 times 5 is 25. Okay, but 26, you cannot get there by multiplying something by itself. So that would be an irrational number because it's a non-perfect square. Okay, so the first thing we're going to be talking about is just finding the roots. So that's what 2-1 is all about, finding the square roots. What times itself is 49, 7, and -7. So technically there's 2 answers there because -7 times a -7 is a positive 49. Okay, same for 81. Well, that's 9 and -9. So if you ever see where it says find the 2, include the positive and negative, that's what they're saying. Or if it says find the 2 roots, that's what it's saying. Okay, that's what 2-1's all about. Pretty easy. Then we go on to 2-2 where we're estimating. And if you have your list of squares, because I usually make a list of squares for myself. So I put 1 squared as 1, 2 squared as 4, 3 squared as 9, and I make this list. Square root of 66, is it closer to 8 or is it closer to 9 is what it's asking. Well, what is 8 squared? Well, that's 64. What's 9 squared? 81. Which one is that closer to? What's closer to 8? Okay. So that's estimating. That's how you estimate it. A lot of similar questions are like this on the MCA where they don't give you a calculator and they say what is it between, what integers is it in between? It'll say something like that. So that's 2-2. That's all about estimating. Okay, 2-3 is simplifying roots. So what you're trying to do is you're trying to pull out the perfect square roots and leave everything else that's there. So they show you a good example. They say, okay, we got 100. Well, that's 4 times 25. Well, the square root of 4 is 2. Square root of 25 is 5. 2 times 5 is 10. Now, you might have known that right away, the square root of 100 is 10 times 10. So if you have a pair, you can bring one out. Outside of the castle is sometimes what we say. We pretend like that's a little castle. You need a pair in order to take one out. So then they did like the square root of 200. Well, that's 100 times 2. Well, we knew that the square root of 100 is 10, so you can bring that out. This is your leftover. He doesn't have a pair, so he can't come out. Now, sometimes what I do, if you don't know your squares at the top of your head, what I do is I just factor tree this. So I would take like number 1 is 98. I would literally break down 98 as much as I can. So I'm trying to figure out what goes into 98. Well, I know 98 could be like 49 times 2, right? Okay, break everything down as much as you can. Well, 49 is 7 times 7. I can't break down my 7s anymore. I can't break that 2 down anymore. Now I'm looking for groups of 2 because a square number is a number times itself. So that's why you need 2 of them. Well, I see a 7 and a 7, so I can bring that on the outside. So I have 7 square root of whatever's left over. Well, the 2 didn't have a partner, so he has to stay inside the root. So number 1 is 7 square roots of 2. Okay, again, if you're doing number 2, if you're breaking down that 600, well, I see 100 times 6, just easily to break it down. Now, if you saw 3 times whatever, that's fine. It's going to break down to be the same. 100 is 10 times 10. 6 is 2 times 3. Okay, 10 is 2 times 5. 10 is 2 times 5. Can't break down 2s, can't break down 2 and 5s, can't break down a 2, can't break down a 3. So that's it. Looking for groups of 2. So here's a group of 2. I'm going to bring that to the outside. Here's a group of 2. I'm going to bring that to the outside. This does not have a group and this does not have a group. So that has to stay on the inside. So the 2 times 3 needs to stay on the inside. Well, 2 times 5 is 10. 2 times 3 is 6. So 10 square roots of 6 is the square root of 600. Okay, just so that you got this down, I'll do 3, break down that 50. I see 25 times 2. 25 is 5 times 5. Looking for groups of 2. Oh, here's a group of 2. Bring it on the outside. 5. What's left over? 2. Okay, sometimes you won't have any leftovers, which is fine because that just means that it was a perfect square. So you can just drop the root. You don't have to put square root of 0 in there. Okay, that's how you simplify the roots. We're just kind of going to go through because this is a quite short chapter. So then I'll assign some IXL with this, as we usually do, because that seems to work really well for us. Okay, so when we're talking about these irrational and rational numbers, okay, they're all a part of the real number system. So they're both, so this whole thing are real numbers. Okay, and then there's 2 branches of real numbers. There's the rational and the irrational. Okay, now irrational numbers, remember, square root of a non-perfect square, pi, those are really the only ones you know so far. And then rational is everything else. Now, if it's rational, you got to ask yourself, can it be classified under something else? So rational are anything that's not irrational. Okay, so that can be any decimals, it can be fractions. Literally, the definition of a rational number is it can be written as a ratio, which is a fraction. Okay, so now after rational, if it's rational, you got to keep asking yourself if you can go deeper in this classification. So as you can see, rational is bigger, and then rational, now integers, is a subset of rational, and then a subset of integers is whole, and a subset of whole is natural. So integers are all no decimal, and they're positive and negative numbers. So your fractions stop here, your decimals stop here, your positive and negative numbers keep going. Okay, if it's an integer, remember it's going this way, you got to ask yourself if it's a whole number. Whole numbers are 0 and above, so no negative. Okay, and then if it's a whole number, you got to ask yourself if it's a natural number. Sometimes your natural numbers are called your counting numbers. And so when we start to count, we count 1, 2, 3, 4. We don't include 0. So the only difference between whole and natural is that it drops the 0. So these are just positive without 0, without 0. So 1 and above. Okay. So then that's kind of how you identify if it's rational or irrational. Whole, integer. They might ask you for more. I got to see what IXL does for this. Okay, this is good to know because this comes up on your MCA. You know, they do that kind of thing. 2.5 is just saying if you had a rational. I'm not really worried about 2.5, to be honest with you. So we're going to kind of skip over that. 2.6 is just comparing which one's bigger. And they always want you to do it without a calculator. I don't care if you would use a calculator personally. You should be able to compare the two. Okay. And 2.7's putting them from least to greatest and greatest to least. So that's not hard. And so I don't know if I exactly will get you something that works with 2.7. I'll have to look at what is offered through IXL. So that should take us to the last one. This is just rational and irrational word problems. So we'll see what IXL has about that. Just again, word problems that are not necessarily hard. It's like right here, it's measured the distance to be approximately that square root. What is that to the nearest 10th? Well, you just put that in your calculator and you find it. So it's not like they're not as hard as everyone makes them out to be. And like this one, if you have to pay $1.25 for each candy bar, how much do I need to get to that? Okay, so you divide the two. So I will assign some IXL for that, and then that should take us to the end of chapter 2, and then I'll have to get you a chapter 2 test. So I'm going to try to get that, like I want this chapter 2 done this week. That's like your goal.